Hello and welcome to the Vault of Truth YouTube channel. In this video, Flat Earth Proof 151, we are going to be looking at how solar radiation pressure will completely destabilize the solar system in a much shorter time than you might think. So, let's jump into the subject matter at hand. In one of my previous Flat Earth proofs, we looked at satellites and all of the things that debunk the possibility of satellites being in orbit around a globe Earth. We looked at this example from the science.org website, and that is for a 12-foot beacon satellite located about 1,600 kilometers above the Earth. The orbit can be changed by a rate of up to 1.12 kilometers per day, so that's about 0.07%, due to solar radiation pressure. So think about a solar sail in that concept, where space engineers have devised a method to deploy a large surface area structure in space attached to a spacecraft that then gets pushed along by solar radiation. You can think of the solar radiation pressure pushing on the surface area of an object as being similar to wind pushing on the sails of a sailboat on Earth. Now, if the solar radiation pressure can shift a satellite by 0.07% at a distance of 1 AU, what would it do to the Earth's orbit? We can use the same 0.07% shift because the ratio remains the same regardless of the size of the object. This is because, much like the satellite, roughly 50% of the surface area of the Earth is being bombarded by solar radiation pressure at all times. Also, another important thing to remember is that as long as the orbits are in supposed equilibrium, meaning they're not drifting inward or outward by any degree, then the velocity of the objects within those orbits is irrelevant. So even though the Earth is supposedly moving much faster in its orbit than the satellite would be moving in its orbit, because they are supposedly in equilibrium, as far as the solar radiation pressure is concerned, it would see these objects as just sitting still. Another thing that you need to remember is that this force compounds over time. It's an exponential. It's not a linear movement. So using the example of the satellite, even though it only shifts by 0.07% on the first day, on the second day, it will shift by a little bit more, and then on the third day, even more, and it will become an exponential curve that will accelerate more and more over time. So now having this understanding, we can calculate how much shift the solar radiation would apply to the Earth over the course of 1 year. So the calculation is simple. We take our 0.07% shift and raise it to the power of the number of days in a year, which is 365, and we end up with a total orbital shift of 129% after 1 year of solar radiation push. That would be enough to destabilize the orbit of the Earth. You can also calculate the solar radiation push force in terms of the total tons of force it would apply to different objects. In this spreadsheet, I added all of the planets and Earth's moon. In order to calculate the pushing force, the first piece of data that we need is the total sunlit surface area of the given object. You can see all of that data there, listed in square meters. The second piece of data that you need is the solar force push in terms of newtons per square meter. This force will be different at different distances from the sun due to the inverse square law of light. I obtained and calculated all of that data and listed it in the second column. I then calculated the push force, measured in tons, and you can see that it's pretty significant. Although you can see that the force really does begin to drop off with distance, especially as you get out to Uranus and Neptune. Now at this point, many globe propagandists will probably try to say that even though this push force is significant, it is very insignificant compared to the masses of these bodies. And they would be correct. This force, even though it looks large in this column, because you're looking at hundreds of thousands of tons of force, compared to the masses of these bodies is very, very small. But you have to remember that in space, in zero gravity, it takes very, very little force to move even a very large object. Let's say, for example, that the Earth were the size of an average house floating in space. The push force that you see there will be the equivalent of something like a mosquito running into the house over and over and over in space, in the same spot and from the same direction. The first 10, 20, 30, 50, maybe even a couple of hundred times that the mosquito ran into the house, you would not see any vector change in direction of the movement of that house. However, after a few thousand times of this happening, you would begin to see a tiny shift in the movement of the house. And then after several million times, the movement would be more and more and more dramatic. And this is why it is so important to carefully analyze all forces working on these objects in space and take every one of them seriously. Especially when you are talking about billions of years. Under that time scale, even the most minute of forces can explode into something huge very quickly. This fact becomes very evident in this orbital shift chart that you see here. Here you see all of the same solar system bodies. The first column has the solar force push in newtons per square meter. I then used all of those different forces that occur at different distances from the sun to create a ratio spread that can then be applied to the orbital shift percentage per day for different objects at different distances. I used the 0.07% orbital shift percentage at a distance of 1 AU as the baseline and then applied the ratio spread to the rest. You can see that the orbital shift per day is very large for Mercury, as it's the closest to the sun, at almost 0.5% per day, whereas Neptune, due to its distance, has a 0.0001% shift per day. It is in the last two columns, though, that the analogy I made earlier of the mosquito hitting the house over and over in space really becomes evident. As you can see, it only takes 1 year for Mercury's orbit to be shifted by 535%. It takes 3 years for Venus to be shifted by 431%. It only takes 6 years for the Earth and the Moon to be shifted by 463%. 15 years for Mars to be shifted by 524%. Jupiter takes 200 years to be shifted by 672%. Saturn takes 600 years to be shifted by 537%. Uranus takes a little longer. It takes 2,400 years to shift 502%. And the Neptune takes the longest at 5,000 years to be shifted 406%. Take note that even though the solar force being applied to Neptune is extremely, extremely small, at that distance from the sun, it still only takes 5,000 years for Neptune's orbit to be destabilized. So this data is showing that in 5,000 years, everything as far out as Neptune inward would have been blown clear out of the solar system, yet they claim that everything is still perfectly stable today after 4.5 billion years. You see a problem there? Now, there is one other argument that globe propagandists will try to make with this. In this diagram here, you can see the balance of forces that make a stable orbit. You've got your centripetal force, the centrifugal force, and of course you got your inertia and the movement or the velocity of the object around its orbit. They will try to say that the solar radiation force was already built into the centrifugal force at the time that all these bodies formed in the solar system, and thus everything is still balanced. Well, this chart debunks that argument. As you can see, it shows the luminosity of the sun over time, starting from the birth of the solar system all the way until present time and beyond. You can see that the luminosity has changed drastically over time. It's had roughly a 30% increase since the birth of the solar system. As the luminosity increases or decreases, the solar radiation pressure force increases or decreases. So this means over time, the solar radiation pressure force has been increasing more and more and more. This means that even if all the bodies in the solar system had this solar radiation force built into their formation from the get-go, and they started off in balanced orbits with the solar radiation force built into the centrifugal force component of the balance of forces, over time, all of the objects in the solar system would still be pushed outward and thrown into space because the luminosity of the sun would be increasing over time, and thus the solar radiation force would be increasing over time. And we're not even taking into account things like the 11-year solar minimum and maximums, and things like coronal mass ejections, which would create momentary bursts of solar radiation force. The solar activity all over the sun is always fluctuating at all times. And this means that the solar radiation force will be fluctuating at all times. So it's game over. So I think we can safely say that if everything from Neptune inward will be blown away into space in 5,000 years, that it certainly wouldn't take more than roughly 1 million years for every last object in the solar system, including all those little objects out in the supposed Oort cloud, to be blown away into space as well. Even if we were ultra-conservative and gave it 10 million years for this to happen, that is still a minute fraction of the 4.5 billion years that the solar system has supposedly been running completely stable. And you have to remember, this wouldn't just be happening in our solar system, it would be happening in every solar system in the universe. None of it would remain stable for very long. So, this is another major debunk of the globe Earth and a great proof of the flat Earth.